What do you call a tall tea kettle on the stove? A hypotenuse. Get it? A hot pot in use. A hypotenuse. Anyways, we will be classifying triangles, and you should find this part very easy, the first part, because guess what grade you learned this in? 6th grade. So let's go ahead and take a look at some angles in triangles. Now, one of the things you learned in 6th grade was that all the angles add up to 180. And you can see I'm moving the point around here, and that one angle can change from pretty much anything down to almost 0 up to almost 180. But here I kept it pretty reasonable. And so you're seeing some of the different angles, and the interesting thing to note is how many angles could I create that were more than 90 degrees. Anytime I made an adjustment, I could make all 3 angles less than 90, but I could never make more than one angle more than 90. So when we are classifying triangles, one of the important things to know is that the angles in a triangle sum to 180. One angle at most can be right or obtuse, because if one angle is right, that's half of the degrees right there, and you have only half the degrees left for the other 2 angles. So only one angle can be 90 degrees or larger. So when classifying triangles by angle, you only need to look at the largest angle. You don't have to look at all 3. So there are 3 different classifications. One is when all 3 angles are less than 90 degrees, and it is acute. Again, you can still look at the largest one, and it still works. The next type of angle is when the largest angle is 90 degrees, and the classification is right. And finally, the last classification is when the largest angle is more than 90 degrees, and the name for this classification is obtuse. Now, there is a special type of angle classification. It's a type of acute triangle. So it's called an equiangular triangle, very special type when all 3 angles are congruent. And this ends up meaning that all 3 angles are 60 degrees. And when you think about that, 180 divided by 3 is 60. So let's take a look at example 1. If you're using my fill in the blank, you're filling in a table. So we're going to find all the angles for each triangle and classify. And so I have 2 of the angles here. How could I find the others? Well, I have to remember that all the angles have to add up to 180. So I set up my equation, 63 plus 57 plus my mysterious angle x is 180. Add my like terms, 63 plus 57. Then I use the subtraction property, and I subtract 120 from both sides, and I get x equals 60. The important thing to look at is the largest angle. Since the largest angle is less than 90 degrees, this triangle is acute. In the next row in this table, we have 43 degrees and 43 degrees. So we do the same steps. Add the 2 known angles plus the unknown angle to equal 180 degrees. Simplify, 86 plus x equals 180. Subtract 86 from both sides using the subtraction property of equality, and I get x equals 94. Now I look at the largest angle, which is the 94 degrees, and that's obtuse. Let me go back up to that. So the 94 degrees is more than 90, so this is an obtuse triangle. Now I have 31 and 59 degrees. So again, same steps. Add the angles, set equal to 180. Combine like terms, 90 plus x is 180. Subtract 90 from both sides, and I get x equals 90. The largest angle is 90 degrees. Since it's exactly 90 degrees, this is a right triangle. Now this one's interesting because I didn't give you any angles, I just gave you a relationship. One angle is 1x, another angle is 2x, and another angle is 3x. I can do the same thing. I can add all 3 of these, and they have to add up to 180. I can simplify, and I get 6x equals 180. Divide both sides by 6, and I get x equals 30. Now I need to find the individual angles. 1x is 30. 2x would be 2 times 30, or 60. And 3 times 30 would be 90. Since I have one angle that is 90 degrees, that's my largest, then this is a right triangle. You can also classify triangles according to the number of congruent sides. One of the first triangles is when you have no congruent sides, and the name for this type is scaling, 0 congruent sides. Now, one you probably remember the name of is when we have 2 sides equal to congruent. You guys like this name. It's isosceles, 2 or more congruent sides. Now, I've heard some people say exactly 2 congruent sides, but our textbook says 2 or more congruent sides, which leads us to the next triangle when all 3 sides are congruent. Technically, according to this definition, this could be isosceles, but the more exact definition is equilateral when all 3 sides are congruent.